Hi CFE friends, thank you so much for being willing to take this research journey with me. I can't tell you how much I appreciate it. I'm so excited about it and I hope that the kids will really benefit from it. So thank you again and here we go. My research seeks to promote student interest in STEM subjects and careers and to develop student computational thinking skills. I hope to achieve these outcomes through the use of a robotics-based intervention which includes multiple components, all of which you will be a part of. The first component is the hour-long We Do Lego Robotics building and coding sessions. The second component is the use of the Use, Modify, Create learning progression, which I'll explain in a moment. The third is exposure to information about STEM subjects and careers via books, videos, and contact with adults who value STEM. And the last is a STEM Learning Center that students will be participating in during their regular class time 3 days per week. So let me break all of this down for you. Here we go. My first research question is, what is the impact of a robotics-based intervention on elementary school age students' interest in STEM subjects and careers? Previous research has shown that students don't connect We Do Lego Robotics to STEM subjects and careers, and we want them to make that connection. We want them to understand that people with STEM skills are in high demand in the job market, that the number of STEM careers is growing rapidly, and that having a strong STEM background is necessary in virtually every field, whether the job you're doing is viewed as STEM or not. We want students to see STEM as something important that they can learn now and use in the future. So I would ask that you help them make that connection. I've asked our GE volunteers, and I hope you will also, talk to students about your life and your job, the ways you use STEM recreationally and occupationally, why STEM is important to you, and how it will be important to your future and theirs. We want students to understand that they have the opportunity to experience success in the future because they have invested in STEM during their school careers. We Do Lego Robotics is a perfect springboard to these conversations. As you talk about the STEM skill subjects they're using during We Do Lego Robotics, please leverage this conversation to promote student interest in STEM subjects and careers. My second research question is, what is the impact of a robotics-based intervention on elementary age students' computational thinking skills? So I will be looking at the impact the intervention has on development of computational thinking skills, as well as how students use the Use, Modify, Create learning progression to develop those skills. But let's start with computational thinking. Computational thinking is the use of abstraction, automation, and analysis to take a complex problem, understand what the problem is, and develop possible solutions using a computer. So there are three pieces to computational thinking: abstraction, automation, and analysis. Abstraction is the ability to solve a problem by stripping it down to its essence. Problem decomposition and pattern recognition are important components of abstraction. Automation is the ability to develop a step-by-step solution to a problem by creating a computer program. And analysis is the ability to troubleshoot and debug the thought processes and programming used to solve a problem or perform a task. Research has shown that computational thinking skills can be developed through exposure to educational robotics. This is a skill set that is and will continue to be in high demand in the workforce and will benefit students as they pursue future educational opportunities and career prospects. So, how can we promote student development of computational thinking skills? To help students develop computational thinking skills, we're going to use the Use, Modify, Create learning progression during We Do Lego Robotics building and coding sessions. The Use, Modify, Create learning progression is designed to support student learning as students develop computational thinking skills and move from being consumers to producers. Students first interact with an existing computational artifact. This is the Use stage. Students develop computational thinking skills by modifying and iteratively refining someone else's project to make it their own. This is the Modify stage. As students gain skill and confidence, they can be encouraged to develop ideas for new computational projects of their own design that address issues of their choosing. This is the Create stage. During the first 12 sessions of We Do Lego Robotics, we're going to focus on Use and Modify. The students will use the We Do Lego Robotics instructions as provided to build and code their robots. The instructions promote some degree of modification, but your goal will be to help students explore further. Please encourage them to think about ways they can modify their existing robot and code. Use the word modify when we talk to students about this. We want that word to become part of their vocabulary. As I said before, the idea behind the Use, Modify, Create learning progression is that students develop computational thinking skills by modifying and iteratively refining someone else's project to make it their own. There are 12 sets of instructions students can use to create robotics projects. However, students do not need to complete all 12 during the building sessions. The skills taught through each project are overlapping, so students will be exposed to all of the coding concepts even if they don't finish all the projects. Students may need to store their projects from week to week so that they don't need to rush through each design. It's more important for them to explore and modify than to finish all 12. At the end of the 12 weeks, we will move to the Create stage. Students will have 4 building sessions to create a novel robot with novel coding. During this stage, you will be encouraging students to test, analyze, and refine their ideas. Some students will be able to do this and some may struggle. It's perfectly fine for students to use or modify designs or codes they have utilized during the past 12 weeks, but the goal is to move students beyond these stages and encourage them to use what they have learned to actually create. Their robotics creations will be displayed in a robotics showcase event during which they will be able to share their robots with other students and community members. As all of this is going on, students will also be participating in a STEM Learning Center during their regular class time 3 days a week. On Tuesday, students will be reading and watching videos about STEM subjects and careers. They will be completing a graphic organizer in their STEM notebooks about what they have learned. I will encourage GE volunteers to ask them about what they've learned and about their notebooks. On Wednesdays, students will be going online to practice computational thinking through coding games and activities. And on Thursday, they will be reflecting on their building and coding activities from their time building with volunteers by answering questions about what they are working on during their building and coding sessions. Volunteers will be encouraged to discuss these questions with students so that students will be able to respond thoughtfully. And that's pretty much all of it. There are a few more bits of information. Students will be working in pairs, so it's 2 students with 1 computer and 1 kit. Encourage students to be careful with their bricks. There aren't any extras. Volunteers were instructed to refer student behavior issues to teachers and to help students with construction and programming, but to use their words and not their hands. Hopefully everyone will be talking to students about STEM subjects and careers and promoting the use of the Use, Modify, Create learning progression. I've asked volunteers to try to connect with students and to stay and assist with cleanup if they are able. And that's it. Please let me know if you have any questions. I'm really excited to get started and I hope the kids will love it. Thank you, thank you, thank you, thank you, thank you.